Welcome to Engineering Practical Lab. This time around, we want to talk about resistor color code. We can measure value of fixed resistor with multimeter. Likewise, we can use color code to determine resistance of a resistor of a fixed resistor. And 10 color is what is being used to denote the value of a resistor. We have 10 colors. So, and we have some resistor have 2 color, 3 color, or 4 color, or 5 color. This number of color is sometimes referred to as band. So when we say 3 band resistor, 4 band resistor, 5 band resistor, it means number of color on that resistor. 3 band resistor have 3 colors. 4 band resistor have 4 colors. 5 band resistors have 5 colors. When you say band, we're referring to number of color on that resistor. If you look at the table, we have this color. We have black, brown, red, orange, yellow, green, blue, violet, gray, and white. And these are tolerance. So we have these 10 colors. We normally have all these 10 colors is normally used on fixed resistors. And it could be 3 of it could be 4 of it. But the common one is 4 band. And that's what we'll be using in practical lab. 4 band resistors, that's the common one. So now, if we look at this color now, for us to remember this color, it might be difficult. But there are some ways whereby we can be able to remember the value very well through some sentence. Once we know those 10 sentences, we can be able to remember this color very well. Black, brown, red, orange, yellow. Black is 0, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, and white 9. Let's look at this sentence so that for us to, if you can remember this, we'll be able to remember a resistor color code. Better be right or your great business venture goes wrong. If you remember this one, you can be able to write color code of the resistor very well. Brown, we have better, well, this is black, brown, red, orange, yellow, green, blue, violet, gray, and white. Black, brown, red, orange, yellow, green, blue, violet, gray, white. If you remember this, you can be able to remember the resistor color code very well. Or you can use this one. This is another sentence that we can use to remember resistor color code. Bad boy ran over your garden, broke very good window. Bad boy ran over your garden, broke very good window. Black, brown, red, orange, yellow, green, blue, violet, gray, and white. Those are the 2 sentences that we can use to remember resistor color code. If you want to remember resistor color code. So if you have, look at this now. Let's say A, B, C. Let's use one to represent color. 4 color on the resistor. Let's say this is the first color, second color, third color, and the fourth color. Majorly, the fourth color normally represents tolerance, either gold or silver. When you have gold or silver on the resistor, it means that's the last color, and the first one will start from the opposite of that one. Let's say this is the first color. So the first color, if you look at our table, first color and second color normally represent significant figure. They are significant figure. While third color represents multiplier, and the fourth color is tolerance. What does it mean? It means that when we want to see value of a resistor, if a resistor have 4 colors like this, the first color will represent a significant figure. Second one is also represent significant figure. The third one is a multiplier times 10 raised to the power C. So this one is a multiplier, and it will now be, this one is tolerance, plus or minus D in percentage. It means that the first color is a figure, second color will be a figure, and the third color represents what? The multiplier, and the last color is what? Is a tolerance. Now let's look at resistor. Assume that we have these 4 colors on a resistor. We have first color brown, second color black, third color black again, then the tolerance is gold. That's the fourth color, fourth band. I've told you that the first one, second one, they are what? They are significant figure. From our table, brown is 1 from our table. But see that brown is 1 and black is 0. So if brown is 1, we're going to put 1. And black is 0, we're going to put 0 because they are significant figure. Then we have the third one is multiplier times 10 raised to power. This is our black is 0. We put 0. Exactly now. So if and then plus or minus gold. From our tolerance, the gold is 5%. Gold is 5%. So it means that when we have brown, black, black, and gold, we have these 4 colors on the resistor. Brown is 1, black is 0. So this third one is multiplier times 10 raised to power is 0. 10 raised to power 0. So then from there now, when I say 10 times 10 raised to power 0 is 1. Any number raised to power 0 is 1. So we now have plus or minus 5%. 10 times 1 is 10. It means that this resistor is 10 ohms resistor. Brown, black, black, gold is 10 ohm resistor. But about this tolerance, we'll talk about this one later. But let's talk about the first three resistors, the first three colors first. Let's leave tolerance for now. We'll discuss about that one later. So that you'll be able to, I want you to know these first three first, because this first three color will give you exact value of a resistor. The fourth band is just a tolerance. And what does tolerance means? We'll discuss about that one later. But if you have brown, black, black on the resistor, it means that resistor is what? Is 10 ohms. 10 ohms. So let's look at another example. So let's look at these three color now and the tolerance, the fourth one. This is the first band, second band, third band, fourth band. This third band and second band, they are significant figure. And this is multiplier. And these are our tolerance. This first three color will give you exact value of that of the resistor. From our table, resistor color code table, red is 1. We are going to put that 1. The red is 2. We are going to write 2. Brown is 1. We have 2. So brown, if you look at brown is 1. We are going to write that 1. 1. So because the first two will give us significant figure. The third color will give us the multiplier times 10 raised to power. What will be the index? Will be the value of orange on the resistor color code, which is 3. Resistor color code orange is 3. And I go put raised to power 3 plus or minus. This one is silver. The fourth band is tolerance. The fourth band is tolerance, and when we have silver is 10%. We now have 10%. So now 21 times 10 raised to power 3 is 1000 plus or minus 10%. So 21 times 1000 will give us 21,000 ohms plus or minus 10%. 21,000 ohms. It means that when you have red, brown, orange, that resistor is 21,000 ohms. Or we can say it's 21 kilo ohms. Kilo means 1,000. 21 kilo ohms resistor. Red, brown, orange resistor is 21 kilo ohm resistor. 21,000 or 21 kilo ohm resistor. So that's that about that one. Let's take another example so that from there we'll now talk about the tolerance. Let's look at this resistor now. Let's take this one as an example. You can see that we have orange, orange, red, and gold here. Orange, orange, red, and gold. Let's go and calculate the resistance value of this resistor now. Orange, orange, red, gold. Now let's go to the board and calculate this resistor. Now let's see now. This is orange, orange, red, as we've seen it from that resistor. So from our table, you can see that when we say orange, so you can see from the table that is 3 and red is 2. So when you have the first band is figure, the second band also particular figure, significant figure, and the third one will be what? Multiplier. That means times 10 raised to power, and the red is what? 2. It will now be 2. So plus or minus, the third one is what? the tolerance. And gold is what? Gold is 5%. 5%. It means that, so this is orange 3, another orange 3. These first two, they are what? Significant figure. The third one we multiplier times 10 raised to power, red is 2 raised to power 2. And gold is what? Is 5% tolerance. From there now, times 3 times 100 times 10 raised to power 2 is 100 plus or minus 5%. So it means 3,300 ohms plus or minus 5%. It means that when you have orange, red as a resistor, that resistor is what? 3,300 ohms. Or we can say, divided by 1,000 to be 3.3 kilo ohms. 3.3, which means that this resistor is 3.3 kilo ohms. 3.3 kilo ohms. So that's that about that. Now, let's now talk about tolerance. When we say tolerance, so we know that this value is this now. The value of this resistor is what? 3,300. If you now have tolerance, tolerance means the range at which that resistor can perform, or the value that we can still use this resistor for, that can withstand the resistor can withstand the value that this resistor can be used for. That's what it means, tolerance. It means 5% of this now, when you add it to it, this resistor will work for it. 5% of this, when you reduce it from this resistor will work for it. That's what it means. So when you say tolerance of the resistor, so it means the level, the range at which this resistor can work. When we say tolerance, what does it mean? You know, we have, when we're talking about tolerance of our table, gold is 5%, silver is 10%, no color is 20%. Though we still have some other tolerance value, but the common one is gold and silver. That's the common one. Gold and silver, that's gold 5%, silver 10%. That's the common tolerance of a resistor. It means the range at which a resistor can perform, the highest value and the lowest value. That when we have, if you have 10 ohm resistor now, so it has a tolerance. It can perform above this. It can perform below this. We can use it for above this value. We can use it for below this value. Tolerance will tell us the level at which we can use it. We can use it for 12. We can use it for 9. So the tolerance is the one that will tell us the range that we can use this resistor. Like for example, now if you have 1 kilo ohm resistor and you have gold, and it has gold as tolerance, and gold is what? 5%. So it means 1,000 ohm resistor plus or minus 5%. So 5% it can perform, we can use it for value above 5% of this. Okay, let's do it like this. Let's find 5% of 1,000. 5%, 5 over 100 times 1,000. This cancel this, this cancel this. 5 times 10 is 50 ohms. It means 1,000 ohm resistor. The 5% of 1,000 is what? 50 ohms. So when we now add 50 ohm resistor with 1,000, it will give us 1,050 ohms. When we remove 50 ohms from 1,000, it will give us what? 950 ohms. It means that when you have 1 kilo ohm resistor with gold as tolerance, we can use it as for resistance value up to 1,050. We can also use it for value below up to 950 ohms. That is, if we need 965 ohm resistor, we can use this resistor for it. For maybe in a circuit that we want to design, what we need is 965 ohms. So because this resistor has this resistance has tolerance, we can use this 1k ohm for this value. Maybe in our circuit, what we need is 1,045 ohms. We want to use it for our circuit. So if you have 1,000 ohm resistor with this tolerance, we can use it because it can still perform up to 1,050 ohms. That's what tolerance means. Tolerance is just giving us the highest and lowest value that we can use, that resistor can can be used for. That's the meaning of tolerance. Tolerance, that is the highest capacity and lowest capacity of that resistor. When we have 1000 ohm resistor, does not mean that we can only use it for 1000 ohms. We can still use it for above and below. But how are we going to know the value of higher value and lowest value? Tolerance will tell us. Let's say, for example, now we see the same resistor, but what we have here is not gold. Let's say we have silver. When we have 1000 ohm resistor with silver, and silver is what? Is 10%, plus or minus 10%. So it means that this kind of resistor, 10% of 1000 ohm is 100. 10% of 1000 is 100 ohms. So now, when you add 100 ohms to this, it becomes 1100 ohms. By the time we remove 10% of this from this, that's 10%, that's 100 ohms from 1000 ohms, we have 900 ohms. 900 ohms. It means that when you have 1000 ohm resistor with this tolerance, silver, which is 10%, 10% is 100, we can use, if we need a resistor of 1100 ohms, we can use this resistor of 1k ohm for it. We can use it because of the tolerance. Even if we need 1090 ohms that we want to use for our circuit, we can use it, 1000 ohm resistor for it, because of the tolerance. It can go up to that. If we need a resistor of 900 ohms, we can still use this resistor because of the tolerance, because it can still perform below, up to this 900 ohms. So we cannot, but if we need 850, we cannot use it. It has go below the tolerance of that resistor. But anything between 1100 and 900 ohms, we can use resistor for it because of the tolerance. But basically, the value of that resistor is 1 kilo ohm or 1000 ohm resistor. So that is the value. Tolerance is just to tell us the range. That's that about that.